Hi, welcome to Block 2, Multiplicative Change, Lesson 6. In today's lesson, you would learn to understand scale factors as multiplicative representations. In your previous lesson, you learned to use multiplicative relationships in similar shapes. Today's lesson will deepen your understanding of what you learned in your previous lesson. Remember to like the video, share the video with those you think can benefit, subscribe to the channel and click on the notification bell so that when new videos are released, you will be notified. By doing so, you'll help us grow our mission to raise maths literacy in children around the world. Thank you. Before we start, I would like you to pause the video and answer these retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So for the first one, you simply do 180 divided by 15 to find 12. So it's an inverse relationship to find 12. Here, 38 times half is equal to 19. Take note that multiplying a number by half or anything by half is the same thing as dividing that number or that thing by 2. Here you're asked to work out the length of the side marked P. Notice that the full length is 13. So if from this point to this point is 9.7, to get P, we can do 13 minus 9.7, which will give us 3.3. Let's look at our first example for this lesson. Here we have rectangles A and rectangle B, which are similar. Take note of the keyword similar. We now know what it means for two shapes to be similar. They must share multiplicative relationships. We are told, or we're asked, what is the scale factor of enlargement from A to B? I want you to have a think. What does the word enlargement mean and scale factor? Of course, you wouldn't know this, but you have already done most of what you need to understand this concept. So scale factor is the multiplicative relationship, which you learned in your previous lesson, between similar shapes, between shape A and shape B. Now, think about it. To find out what number you would multiply 12 by to get to 48 is the same thing as doing 48 divided by 12. So, we are multiplying shape A by 4 or scaling shape A by 4 to get shape B. So we say the scale factor of enlargement from A to B is 4. Let's look at this one. Another example. Rectangles A and B are similar. What is the scale factor of enlargement from B to A? Notice how we have changed the language. Well, to get from B to A, have you noticed that we have to think, well, if we multiplied by 4 to get from A to B, what would we be doing to get from B to A? We are making things smaller this time. Now, that number is to divide by 4. Well, to divide by 4 is the same thing as multiplying by 1 over 4. So I want us to stay consistent, to start using the consistent multiplicative relationships which we use. So each of the sides, corresponding sides, would be to divide by 4. Now, something you need to know is even if you make a shape smaller, we still use the word enlargement. So the correct way to say it is the scale factor of enlargement from B to A is to divide by 4. But remember what I said. We want to stay consistent with the language of multiplicative relationships. So, divide by 4 doesn't sound quite right, does it? So let's change it. It is to multiply by a quarter. So the scale factor of enlargement from B to A is 1 over 4. Let's look at this example. Rectangles A and B are similar. What is the scale factor of enlargement from A to B? Well, notice that to find out the quantity or the number that we need to multiply 10 by to get to 15, another way to find that out is by doing 15 divided by 10. So that gives us 3 over 2, which is 1.5. So we can say the scale factor is 1.5, or we can confidently use the fraction 3 over 2. So when we are asked to state the answer to the question, what is the scale factor of enlargement from A to B, we can say that the scale factor of enlargement from A to B is 3 over 2, or 1.5. And of course, notice that the scale factor is the same for all corresponding sides between the shapes that are similar. It's now time for you to practice what you've learned. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. So for question 1, A and B, we can see that the scale factor is 3. Why? We see the multiplicative relationship to go from shape A to B as 3. And then to go from shape A to B, we see the multiplicative relationship is 1 over 4. For C to D, for question C and D, we see that the multiplicative relationship here is a half. So if we multiply 20 by half, we'll get 10. If we multiply 20 by 2.5, we'll get 50. Now, I just want to repeat, how did we get 2.5? You could have done 50 divided by 20 to get 2.5. Let's look at another example for the second part of the lesson. Triangle B is an enlargement of triangle A by scale factor 5. We've been asked to work out the base and height of triangle B. Now, remember how multiplicative relationships work. If the scale factor is 5, it means if we multiply the corresponding base and the corresponding height, we will get the corresponding length of the base and the corresponding length of the height. So 7 times 5 is 35, hence 3 times 5 should be 15. It's now time for you to pause video and answer question 2 in 1 minute. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. So for question 2, we're asked the rectangle has a length of 12 centimeter and a width of 9 centimeter. We're asked to work out the length and width of the rectangle if it is enlarged by the scale factors. So if it's enlarged by the scale factors, you just need to multiply the corresponding length and width by those scale factors, and this should be your answers. For C, D, and E, these are the answers when you use the corresponding scale factors to multiply the length and the width. Pause video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. For question 3, we're asked that these hexagons, so don't be surprised it's called hexagon. You can see hexagon has 6 sides. It has 6 sides. So We ask, what is the scale factor of enlargement to get from this shape to that shape? Remember how we work it out? You could have done 15 divided by 10 to find out that the multiplicative relationship is 1.5. Now, to get the length of the corresponding sides, we could multiply 9 by 1.5 and then 5 by 1.5. Now, to find out the missing lengths, if we know that this side is 7.5, then to get this side, we know that it has to be 15 minus 7.5. Then if we know that this is 13.5 and this is 4.5, to find this length, we could do 13.5 minus 4.5. And that answers the question. Pause the video and answer question 4 in 3 minutes. Assuming you've paused the video and you've answered question 4, here are the answers for A and B. So you were asked, what is the scale factor of enlargement from shape X to shape Y? You can see from shape X, you have 2 squares. And for shape Y, you have 6 squares. Now, the multiplicative relationship to get from 2 to 6 is to multiply by 3. And then you ask, write the ratio of the width of X to the width of Y. It is 1:3. So if you wrote 2:6, and then you simplify that ratio, you will get 1:3. Here are the answers for C, D, E, F, and G. So mark your work and celebrate your success. Now you're being asked to explain any connections between your answers. Notice that all the ratios are 1:3 because the scale factor of enlargement is 1:3. So if the scale factor of enlargement is 3, then it means the ratio of any of the sides, corresponding sides of the smaller shape to the bigger shape will be 1:3. Pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. For question 5a, you were asked, Mo has some enlargements made of the photograph. Find the length and width of the photograph if it's enlarged by a scale factor of 5. Well, if it has been enlarged by a scale factor of 5, then the scale factor will multiply the length to get the corresponding length of the enlarged photograph. So 30 times 5 will be 150 and 12 times 5 will be 60. And here are the answers for B, C, and D. So we asked to find the length and width of the photograph if it is enlarged by a scale factor of 3.6. We simply multiply 3.6 by the corresponding length and the corresponding width. And it's the same if we're asked to find the width of the photograph if its length is 84 centimeter after an enlargement. So if its length is 84 centimeter after its enlargement, to find the scale factor by which we have enlarged it, we could have done 84 divided by 30 to find that special number, which is 2.8. And it is that number that we can use to find the width by multiplying 12, which is the width of the photograph that has not been enlarged, to get the width of the photograph that has been enlarged. And it's the same process we would use to get the answer to question D. And that brings us to the end of this lesson, where you have learned to understand scale factors as multiplicative representations. Well done for taking your learning seriously. Until next time, take care of yourself and bye-bye.